All right, my friends, let's look at this beastly 2018 problem one here. I don't know if you can imagine being part of the class of 2018 that had to take this test, but boy, they were really, let's just say this test was a big day ruiner for a lot of people. But I want you guys to remember something. If the test, if your AP test this year makes you feel really horrible, then just know that that's how everybody in the nation is feeling, and who's taking that same test anyway. And they're gonna have to normalize the scores. So, so the years that they make the tests really, really horrible, then the number of points that it takes to get your 3, 4, or 5 is always lower. So just know that if the test is hard for you, it's hard for everybody else. And so just do your best and it'll add up and it'll end up being just fine, okay? So for this problem here, it says people enter a line for an escalator at a rate modeled by the function lowercase r of t here. So we'll just have to remember that that's a derivative of the amount of people who are entering the line. And then it says r of t is measured in people per second and t is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 of a person per second, and there are 20 people in line at t equals 0. So, so I think I will just add a little bit of notation. So they exit the line at a rate of 0.7 per person per second. So, you know, you could add your own notation for that. I could say the rate at which people exit the line at any time t. I don't know how necessary that notation is just 0.7. And then you could always, people or person, you know, you could always add your units of measure there. And then when it says 20 people are in line at t equals 0, you could, you know, consider that, I guess, I don't know, just remember that's kind of an initial value that we'll use at some point, okay? So I'll just kind of underline that. I don't have any great notation for that right now. Okay, so part A, it says, how many people enter the line for the escalator during the time interval from 0 to 300? So if this is the rate at which people enter the line, if we want the number of people who have entered the line, then we'll need to do antiderivative. So, my plan for part A is simply to do the integral from 0 to 300 of r of t dt. And then r of t on 0 to 300 is defined as this function here on the top. So to do that, I've already typed it in, so I won't bore you with those details, but so I just type in r of t as given, and then just do, you know, our usual insert that function, integrate with respect to x, and then use your appropriate bounds. Okay, and there we go. So I would say 270 people have entered the line on the time interval from 0 to 300. So there you go. Okay, that's part A. Part B, during the time interval from 0 to 300, there are always people in line for the escalator. How many people are in line at time t equals 300? So for this, I just want to break this down in words, and you of course would not need to write the words, but hopefully they're helpful for you for just kind of keeping this as basic as possible. So if we want to know how many people are in line at, 300 seconds, I guess, into this story, then here's my thought process. So number of people in line at time t equals 300 would be found by taking the number of people in line to start with. So at t equals 0. And then we're going to add the number of people who enter the line during the time from 0 to 300. And then we're going to take away the number of people who exit the line. On the time interval from 0 to 300. Okay, that's my plan. So what would that be? So how many people were in line at the beginning? So that's what this is for. 20 people were in line at the beginning. So this little piece right here is 20. Okay, and then how many people entered the line from 0 to 300? Well, that's what we found in part A. We found out that 270 people entered the line. Now for the number of people who exit the line from 0 to 300, we're going to subtract that off. So it's a constant rate for the people who are exiting the line. So if you just take that rate and multiply it by the amount of time that's passed, you'd find out how many people have been able to leave the line. So 300, and I'm going to put units of measure in here just to like make it really clear that this makes sense. So 300 seconds would have passed, and you'd multiply it by 0.7 people or person, whatever you want to say there, per second. So the seconds cancel, and then you can see that you really would just end up with number of people there. So 300 times 0.7 ends up being 210. So we'd end up with 20 plus 270 take away 210, which ends up being 80 people. There we go. So that's how many people would be in line at time t equals 300. Okay, part C, it says for a time past 300 seconds, what is the first time t that there are no people in line for the escalator? So I'm going to put my thoughts in words, and then I'll show you how that works out. Okay. So my thoughts in words here is basically we want to figure out, if you take the number of people that are in line at t equals 300, if you take away the number of people who are exiting the line, at any time, and I'm just going to say any time x, and then what x means this is number of seconds past t equals 300. Okay. So if you've got number of people in line at t equals 300, and then you start figuring out, taking off the number of people who leave the line, we want to figure out when is that equal to 0. Okay, so how many people are in line at t equals 300? That's 80. So we found that in part B. And then the number of people exiting the line at any time x, where x is the number of seconds past t equals 300, that would be 0.7 times the amount of time that's passed there. And then we're looking for that to be 0. Okay, so solving this, you just add the 0.7 over and divide, so you end up with x would be whatever 80 divided by 0.7, and that ends up being approximately 114.285. But keep in mind that this is the number of seconds that have elapsed past that 300 for initial 300 seconds. So this would result in a time of the initial 300 plus the 114.285. Okay, so therefore, the first time that there will be no people in line, will be at t approximately 414.285 seconds. There we go. All right, my friends. On to part D, which I think a lot of people just had a question about part D. So let's look at that. I'll probably need to refer to some of the stuff that I already have here, but we'll see. So part D says, for time between 0 and 300 seconds, at what time t is the number of people in line a minimum? To the nearest whole number, find the number of people in line at this time. So they're asking you for two things. They want you to find the time t at which the number of people in line is a minimum, and then they also want to know what is the minimum number of people. And justifying our answer is going to be easy. That's just our work, okay? So for part D, so I do like keeping track of my thoughts just in kind of that 1/2 structure. So what is it we want to do? So we want to minimize the number of people in line. For time values from 0 to 300. Okay, so let's think this through. If you want to minimize the number of people in line, that means if you can get a function rule that represents the number of people in line, then all you'd have to do is figure out if you knew what the function rule looked like, whatever it looks like. If you're looking for the minimum, then you'd be looking for when its derivative changes from negative to positive. And then of course you probably check endpoints just for good measure type thing. But really the plan is this: get a function rule for the number of people in line for this time interval, then take its derivative and look for when its derivative changes from negative to positive. That's the plan. So let's talk about what we have to work with. So the first thing I'm going to try to do is get a function rule for the number of people in line. And what I'm going to do here is I'm going to do it for a number of people in line for a time called x. So I'm going to use x to represent this certain times, this mystery time value between 0 and 300, okay? At a time x from 0 to 300, okay? And then, okay, and I didn't realize that I needed to change my letters until I kind of got into the work that I'm about to do, but you'll see pretty soon why you'll want to use an x here. So I'm going to call my number of people function n of x, number of people at some time x. Okay, so how many people would be in line at some time x? Well, we're going to go back to the plan that we used before, where really it's just number of people aligned to start out with, plus how many people entered the line, take away the number of people who exited the line. But instead of for all t, it's for some x value from 0 to 300. So how many people were in line to start with? 20. And then how many people would have entered the line at some time x between 0 and 300? It would be the integral from 0 to whatever that x value is of the rate at which they were entering the line with respect to time. And then take away the number of people who have exited the line at this time x. That would be how much time has passed times that constant rate of 0.7. So you've got how many people you started out with, how many people entered the line, and how many people exited the line at this time x. Okay, so this is my function rule. I could clean it up. I could write that a little cuter, 0.7 times x, but I'm not going to bother. So here's my function rule for number of people in line. Well, what was my plan to minimize the number of people in line? It was to look for when the derivative of this function would change from negative to positive. So now let's take the derivative of both sides of this equation, and I'm going to take the derivative with respect to x. So on the left side, what's the derivative of this with respect to x? It's n prime of x. Now let's do the derivative of the right side. What's d dx of 20? It's 0, which of course you don't have to write. And then I'm going to dirtbag math this piece here for a second. So I'm just going to say we need to do d dx of the integral from 0 to x of r of t dt. And then we would take d dx of this piece right here. And so d dx of 0.7x would just be 0.7. Okay, so now for cleaning this up a little more, let's look at what would the fundamental theorem of calculus say about this integral. So, and we're going to leave the d dx off to the next step. So we would have big R of x take away big R of 0. And then we also have that little minus 0.7 there. Keep in mind, big R of 0 is a constant, so when you take its derivative, it would go to 0. So what do we have now when we take the derivative? d dx of big R of x would just be R of x. And then we'd have that little minus 0.7 there, just from the derivative of the number of people that were exiting the line. So here we go. Like so. Okay. So now what was our plan again? To minimize the number of people in line, we needed first the function for the number of people in line, then we needed the derivative, and we're going to look for when the derivative changes from negative to positive. So bring my calculator back here. If you think about what I'm saying here, it's really just what we already had typed in for y1. It's just we have an extra minus 0.7 at the end, okay? The window should be from 0 to 300, and then let's use zoom fit to have the calculator kind of decide what it thinks we want to see. It's usually right. Okay, so here's the graph of n prime. I'll just make a note here so I can have something to draw on. So here's 0, here's 300, and this is the graph of n prime of x. Okay, so it goes okay, and so the critical numbers for us to consider here would be time values equal to the endpoints, so 0 and 300, and then the place where the derivative changes from being negative to being positive. So that would be this guy right here. Okay, so let's use the calculate and 0 feature of your calculator. We're looking for this first place where your derivative changed from negative to positive. So just go a little to the left and a little to the right and have it guess. And so you've got 33.013298. So. Okay, and then up to you what you want to do with this decimal value. You're welcome to use the store as features. So store as, and then alpha, whatever letter you like. I usually use A unless it's being used already. So you don't have to retype that decimal in again. Totally up to you if you like that idea or not. Okay. All right. So now let's figure out, okay, what were we supposed to do? We were supposed to figure out at what time do you have the minimum, the absolute minimum value, and then what is the absolute minimum value. So basically we're just going to compare the number of people in line, which I chose to call n of x, so I'll just use that notation. So the number of people in line at 0, number of people in line at 300, and then number of people in line at that 33.013298 value, okay? So how many people were in line at 0? That was that given information of 20. How many people were in line at 300? We found that in part B, that's 80. And then now let's figure out how many people were in line at this point. So I am just going to go to figure this out. I'm just going to follow my own rule here. Okay, so this is my function rule. So I'm just going to plug 33.013298 into that. Okay, so this would be 20 plus the integral from 0 to 33.013298 of r of t dt minus 0, oops, sorry. So we're going to put, that number in here as well. So 33.013298 times 0.7, like so, okay? So let's just make our calculators do the work for us, and then we'll write a little sentence answer and be done with it. So I'm just going to do 20 plus math, function integration, totally, you know what I need to do? R of t doesn't have that minus 0.7 on it. So if I'm going to use, I need to take that off with the right buttons. Okay, there we go. Okay, there we go. Okay, so now I can do function variables, y1, boom, 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 0. I can put a in for that number there, minus a again times 0.7. Okay, so there we have it, 3.803. There we go. Okay, so now let's reread the question real quick. It says, at what time t, so that would be, here's my t right here, is the number of people in line a minimum? Well, I had 20, 80, and 3.803, so I'm going to go with this for my minimum. It says, to the nearest whole number, find the number of people in line at this time. So I'll just round that to a 4. So I'll just say roughly 4. That's not a real math symbol, but Okay, anyway, so final answer, so happy to be almost done with this problem, is the number of people in line for t from 0 to 300 is approximately 4 and occurs at time t approximately 33.013, actually, yeah, there we go, seconds. All right, my friends, that's that. I hope that helps. And hang in there. Boy, 2018 was a monster. I'm pretty sure the people who wrote the test, I think they got fired after 2018 because 2019 was not nearly as bad. I think they either got reprimanded or we got a new crew. But anyway, hopefully those 2018 people aren't writing your test this year. And if they are, then just know that if you're struggling, everybody else in the nation is too. And just write your own version of what your answers are and just move forward. All right? All right, take care, everybody.